Thank you very much, Lena. And thank you, Stina and Björn and everybody in the team for inviting me to speak this day. And it's a hard act to follow Heideli's Als herself when I'm going to present now, but it's also a great privilege. I hope some of you are wearing these nice green labels for World Nidcap Day. I want to say that I got mine directly from the hand of Heideli's Als. Just note that. So this is a privileged day and an auspicious day celebrating these different things. And this topic also, circadian rhythms and sleep in the developing brain, NIDCAP, neuroglia, and future research. So circadian rhythms is something which I mentioned in a talk that I gave last year. And then I talked about skin-to-skin contact and state organization. So now I have to go on and talk about what does healthy sleep looks like, what is healthy sleep, why is healthy sleep important, and I'm going to share some preliminary results that I whispered in Stina's ear last year. So the first question is, why is it important? I actually spoke about last year. And so very quickly I want to review what I said last year. It was about pleasurable feeding. And I wanted to show its direct link to sleep as a physiological rhythm. And that physiological rhythm is not circadian. That circadian rhythm is a master clock and it drives other clocks. But there are ultradian rhythms. They are shorter than circadian rhythms, and the newborn baby does not have a circadian rhythm. It only has ultradian rhythms. Not only are those ultradian rhythms particular and specific, they are a 1-hour rhythm. And so the pleasure, and they come from the hypothalamic centers of hunger drives and satiety drivers. And they come also from a master clock that produces a 1-hour sleep cycle. I'm doing this very quickly. You can see here that feed, sleep, wakefulness is a single clock, master clock in the hypothalamic centers that regulate all metabolic processes. So at a higher level, where we know the importance of the circadian rhythm in adults, there is another cyclicity in the fetus and in the neonate. And Heideli's told us that a preterm is a fetus outside the womb. Inside the womb, the fetus has 1-hour sleep cycles. And here they are. And then why is it important? Again, Heideli's also has introduced this to us. And Mandy, where's Mandy? She knows more about this from a very personal point of view. It is during sleep that the brain wiring is taking place. This is a slide from Perano, a review. Sleep-wake cycles is the functional integration of every aspect of brain development. For you and I as adults, we can remember because we've slept on it. But for the child, sleeping on it is how you're making the capacity to remember. So there's a 1-hour sleep cycle. And then I presented data to show that the capacity of the stomach only holds enough food for 1-hour volume of food. Then the stomach is empty and the baby's hungry. So rhythms. Ultradian rhythms. There's a synchronized stomach rhythm and brain rhythm for sleep. And you can see the stomach emptying and filling in fetal scans in a 1-hour cycle. And this pleasurable was a nice word you used. And I was saying if it's pleasurable, it's also physiological. If it's unpleasant, it's not physiological. So with this introduction, I was saying that pleasurable feeding and sleeping is a physiological rhythm. So, 2019, ultra early. Focus on healthy sleep. Why is healthy sleep important? I think I've answered. Now, what does healthy sleep look like? we all know what sleep looks like, and we can measure sleep. It's a very, very different issue to know if that sleep is healthy. How do we know it's healthy? Well, we can only check it if we can compare it to something else, and we can follow it up for 20 years or even a few years. So I want to lift out this piece. What does healthy sleep look like? And so I'm coming back to this. It's got to be synchronized, and it's got to be based on what we know is our biology, what we know is our developmental needs. So, healthy sleep. I think the first thing I want to say about it is that there is a synchronization of all metabolic processes in the brain, which is well established in the fetal stages already. So let me share some results from my research, and I'll show you soon a picture of my colleague that I've done this research with. State organization has been the focus of this research, and skin-to-skin contact. This is a series of studies, all of them done with honors students. After their basic degree, they have to do a 6-week study. So what you're seeing me present here, a long list, are 6-week studies done by students. That's all. If you think they're inferior and limited, give high praise to my 6-week students who did a fantastic job in each case. And you will see here that there's Barak, my research partner. We worked a lot with a neonatologist called Alan Horn. We started with bigger babies, and then we've worked our way down to smaller babies, looking at them in different ways. We started with big babies doing heart rate variability, impedance cardiography, and EEG. I will show you this. Then we went to smaller babies. And then we went to even smaller baby looking at different aspects. So now when I present this, I'm going to do it the other way around. This is ultra early. We are an ultra early. So I'm going to start showing you some results from 32-week babies. And my ethics committee will not allow me to study babies below 32 weeks for some good and bad reasons, and I'll show you a good reason in a moment. These are a few of my students. So, we started our study on the basis of what we call a place model, that the environment, I at least mentioned the environment, the ecology of where the infant is, as a primary overriding determinant of what follows. And in our first study, we had babies in cots, 3 feet from the mother, compared to skin with the mother. And then throughout the recordings, we code the place as a 1. We did more sophisticated places. Here's Ashley, and here's my wife, and we're designing a study where the infant can be its own control. And so here, the baby is in skin, prone and tilted. That's what skin is. Here, the baby is prone and tilted. I couldn't quite put the baby supine and tilted, but I could put the baby prone and supine. And so I'm mixing a little bit place and position. And the baby is its own control in these places. The state coding, Liz, here's your Brazelton scale, now modified by Jean Cranston Anderson. And so we use her 12-point scale. I have put breastfeeding as a state. It's also a place, but it's a key part of, remember, I have to do this because I linked sleep and feed as a single state organization. Am I putting something novel in your mind? It's a single state organization. And again, I can code the numbers. Oopsie, I jumped a slide. And so in this way, into the computer, we enter place and state. And now we can measure the neural axis. The neural axis has a prefrontal cortex, and you've heard already today about the orbital frontal. That's our social brain. And the medial prefrontal cortex has a executive function and an approach avoidness that determines safety of the environment. There's your cingulate, insular, amygdala. I don't have time to talk too much about all of this. In this particular neural axis, we're looking at heart rate control, seeing that it has a sympathetic activation control and a parasympathetic. This is neurovisceral integration. This is integrating the brain and the body. And state organization, what Heidel-Alz has taught us, is that when you look at the body, you can see what the brain is telling. You can read the baby's mind if you look carefully at its body. And so this neurovisceral integration and state organization and developmental care, can I present it to you as a package where we can measure these things? Now, I didn't do the developmental care NIDCAP training because I don't have a training center in Cape Town. And so I chose rather to do these measurements by physiology outcomes. The EEG, and now I'm talking to the prime expert on the EEG in the world, it's a bit embarrassing. We're measuring in the frontal lobe only, where we get this approach avoid centers. The heart rate variability is the bottom end of the axis, and the impedance cardiography is a sympathetic signal. I'm doing this slowly, and I hope I'm not taking too much time. Are we all okay? You've got to understand where I am now. So the heart rate variability is a validated measure of parasympathetic control of the organism as a whole. And what we have done, Barak and myself, is made algorithms of our own where we highlight the importance of very low frequency. And I can say it up front, our hypothesis is that this reflects the unmyelinated, vagal parasympathetic that also controls the gut, and that before controlled the heart. 3 leads for that. We have to add 4 leads to the ECG to get impedance cardiography. And this is why the ethics committee gets a bit upset. The reality check is that there's a lot of leads to put on a 32-week body, especially when I've got adult leads and I haven't got the resources to find other leads. In the news last week, there's an epidermal electrode. Did you see that? Let's talk to each other, see what we can do more. So now, the impedance cardiography, and again, I don't have time to explain the detail, allows us to see the power that the heart is responding with. It also gives us a chronological, a time signal. And so analyzing the impedance cardiography windows, and here is, you're going to speak to us soon, that's where the machine comes from, and I had to get special help in coding the software, because these were small heartbeat intervals. But we get an inotropic and a chronotropic outcome of sympathetic outputs. So in this way, I've got 4 separate signals. I've got 2 cardiac sympathetic and 2 cardiac parasympathetic measures, where I can see the power of control on the autonomic nervous system measured through the heart. And then just these 2 leads, the left frontal and the right frontal. Bit reversed from what you might have thought. The right frontal activates an avoid signal. The left frontal activates an approach signal. And mathematically, we just subtract the log scores of those 2 powers, and if you're above the line, it's indicating an approach. This is a validated measure in adults. We're using it not as a stray measure, we're using it as a state measure in real time, and we're doing it in infants. So now we take these different signals, the 4 that I mentioned earlier, the place, the state, and we produce this very messy slide. It's not messy, it's very pretty. Are you okay with me? is very pretty. It shows everything that you might want to know. And the place and the time and the state is at the top. And then there's the heart rate variability data. And then there's impedance cardiography data. And then the EEG. And now we can look at pattern recognition. And we can correlate place with state organization and what is happening to the child and what the baby's brain is doing. Are we okay so far? I've described the research protocol. So I did mention I'm going backwards. So here we are. We're going to look at the same babies. So these babies get rigged up at about 6 o'clock in the morning, and then the student has to stay there. There were two of them helping each other because they measured different things, until 2 o'clock, doing continuous measures. The instructions are to randomize the starting position, and then to do a sequence of other positions, and to fit that in to the ward care in such a way that it is not interrupted, by all the different things that happen to babies in the ward. At 9 o'clock you've got to be fed and all of those things. So we've taken that into account in ensuring that the babies will spend 4 hours, 1 hour each at least, in each of these positions. Notice that there's a transfer from skin to tilt. The transfer from tilt to prone is totally smooth and seamless. The transfer from prone to supine can be done quite smoothly. So, are we okay so far? Now, the infants are their own control. And so here, I've just described the place order being randomized here. Now, the objective is to look for sleep. The nice thing about the very low frequency is that it specifically is a marker for the onset of quiet sleep. Very neat. Yes, the respiratory rate is another marker for quiet sleep, and there are some other markers for quiet sleep. And if I look very carefully at our polygraphs, I can find 4 markers from what I'm collecting of quiet sleep epochs. Notice, quiet sleep epochs. Sleep cycling, you mentioned, is coming next. So these are purely quiet sleep epochs. And so now you're going to see a run-through of the 8 cases. Now, I haven't hidden any cases for you here. And all I've done here is that where I've got these 4 conditions, I've put a blue bar. Does it show with my pointer and your thing like that? There's a blue bar and there's a blue bar. You, from where you're sitting, can't see where the baby is during this quiet sleep. Nor can the computer when I code the stata extraction of this information from it. But what I'm showing you is the visual graphic. First case, 2 sleep cycles. Third case, second case, 3 sleep cycles. 3, are you okay? You don't need to see more? Another 2 sleep cycles, 2 sleep cycles, 2 sleep cycles, 4 sleep cycles, 1 sleep cycle. Now, I'm cutting up the pieces so that all the ones of the babies that are supine, I can see how much quiet sleep epoch they had. And I'm only looking at quiet sleep. I'm not looking at the various physiological parameters. So there were 2 quiet sleep epochs when the babies were supine. 3 when the babies were prone. And 2 of those 3 were in the same baby. So there was 2. Tilt. 1, 2, 3, 4, 5 babies had quiet sleep epochs when they were tilted. Heidel's mentioned tilt in terms of the feeding as a benefit. But here you see that tilt is benefiting there, sleeping also. Now, in skin-to-skin contact, 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I was a little bit more generous, I would have given a 10th. But I was quite strict when I looked at what I defined as sleeping criteria. Every baby in skin-to-skin has a sleep cycle. Heidel's mentioned that sometimes she could only get sleep cycles when the mother were holding them. And so mother's presence, place, is determining the presence of a quiet sleep epoch. What about the sleep cycle? I'm missing a few instruments to make this a true polysomnograph. I didn't call it that, I call it a polygraph. Somnographs, you need an EOG. I don't have an electro, and one could add some other signals. But what I want to look for are another 4 objective measures. One is what we call sleep latency, how long it takes for the onset of the quiet sleep to take place. And then we want to see that the baby's state when it awakes is a gradual awakening. So I can make some objective criteria to go back to the quiet sleep epochs, which are a prerequisite to define a sleep cycle, and see which of those quiet sleep epochs matched a decent sleep cycle. And there are fewer of them. I have to subtract some of them. So there's an effect of place on the presence of sleep cycling and of sleep epochs. Let's look then deeper at what is the underlying physiology. Now we're looking at the whole long length, and I have parasympathetic and I have sympathetic measures. This may look messy, but it's actually very beautiful. Do you agree? Thank you. There's our heart rate, and here is respiratory rate. So I can see the breathing on what's called tidal volume from the impedance of the machine from Utrecht, which is right here. And there are sympathetic measures, and here are parasympathetic measures. And because I've got a time measure and a power measure, the software will calculate a cardiac output, a stroke volume, or a minute volume. So, prone and supine are not very different physiologically. They look very similar with the level of acuity that I can get from this data. There is actually increased power, therefore more autonomic stress in supine than there is in prone. And those results show fairly clearly. But it's not a dramatic difference. Cardiac output is about the same. It's a little bit lower in supine than it is in prone. But they're about the same. So, autonomic power in prone and supine is much higher than in tilt and than in skin-to-skin contact. It's highest. Tilt, on the other hand, you can see here is the tilt period. The cardiac output is lower, and the power of the autonomic nervous system is not much lower than prone and supine. So there are some differences, but it's not too different from prone or supine. In skin-to-skin contact, there's a profoundly different physiology. Perhaps the most striking thing you see is an almost doubling of the cardiac output, the minute volume. It is twice as high as in tilt, prone, or supine. And the other striking feature is that the autonomic, sympathetic, and the parasympathetic are profoundly lowered. It's a much different autonomic state. And so there's an effect of place on the sympathetic systems in the slide and on sleep and parasympathetic systems in the slide. So I took a bit of time now. I've got to scream through the study from Mika. He did 9 patients, and I can't show you all 9. Now he did a slightly different thing. He rigged up his babies at 7 o'clock in the morning. At 8 o'clock, they had a feed. And then we made sure that nobody disturbed those babies until 10 o'clock when they had another feed. If there was a disturbance, we recorded it. In this way, we got 2 hours of uninterrupted time. So that's how we managed that. And so as I've presented the data here, you see that that blue block is breastfeed. And there's a breastfeed block over there. And this baby in skin-to-skin has 2 good quality sleep cycles. Tomorrow, the baby comes back and now has exactly the same procedure in the crib. next to the mother's bed. So it's the same time, but tomorrow. And now you see that there's one single sleep cycle, but there is a profound avoidance behavior in these babies. The ethics committee would let me put EEG leads extra on these babies. So these poor babies were really rigged up, but they're a bit bigger and a bit more robust. And you will see here also that the stroke volume of these babies and the sympathetic signals on these babies is much higher. So again, 2 sleep cycles in the 2 hours that it's undisturbed. Here, that little bar indicates a disturbance in the middle. But it came in the middle of 2 sleep cycles. I was lucky, or Mika was lucky. But here you see the same baby. This might have been the day before, but I'm just presenting in this order. There's a profoundly enhanced sympathetic nervous system enhancement, power signal when the babies look as if they're asleep. I might have been a bit generous in giving this baby a sleep cycle, but I did. And it's not the same quality of sleep at all. And so here is 2 full sleep cycles, and here you see some sleep epochs, but just look across the other side how very different the sympathetic and the power and the parasympathetic signals are. And you see this profound avoidance behavior that's taking place in the higher end of that axis. And so I'm now beating on the same bush. Are we okay? So the maternal place profoundly, and one more thing I wanted to say. These sleep cycle patterns are almost adult in terms of what you look in the literature. A baby that is sleeping in its own will develop this kind of mature sleep cycle at 2 months and 3 months of age. These babies are -1 month of age, and the place of mother is making that difference. So, the third study, Barak, myself, and Alan Horn, we're looking at babies, and they are 2 days old. All of them were born by cesarean section. That's how I can get them at 2 days old. And I can get them safely on the second day because the mother's only going home tomorrow. And so they're a convenient sample of babies possible to study. Are you okay? So they're biased in the sense that they were born by cesarean. And they will spend 1 hour without interruption in skin to skin. And now the without interruption is the necessary part of the intervention. If they're interrupted, we have to start the hour again. So we get a full uninterrupted hour. And then we randomize the order. The babies are their own controls. So here are just 3 of the 16 babies that we've published, and you see a very typical pattern. This is a 1 hour, and there you get the quiet sleep, and there you get the active sleep. Active sleep, quiet sleep. All of the babies show this pattern. Depending on the interruptions, you'll see something else on the pictures that we have. The very same baby, in its opposite hour, doesn't have a sleep epoch or even a sleep cycle. And so these babies are more mature than the others. You saw 32 weekers, you saw 36 weekers. At 40 weeks, these babies have a repertoire of behaviors which is more mature. And the sum of it is, in biological psychiatry, Jaak Panksepp is one of the editors, he allows us to say that skin-to-skin contact is our normal. And so if we put a baby out of its normal place, it trebles the autonomic power. And it abolishes 86% decrease in quiet sleep. And the sleep latency we've measured very carefully, and the babies fall asleep quickly, and the separated babies do not. So the title of our paper was, Should Neonates Sleep Alone? And the answer is no, because they don't sleep alone. They don't sleep when they're alone. So I'm coming to this very slowly. I started by saying it was about place. And then I shifted to separation. And so this one baby, which has this pattern of signal on its polygraph, here's the rest of that baby's polygraph. You can see that the baby here was in skin to skin, and it was approaching. Breastfeeding made an intense approach activation of the frontal lobe, the medial prefrontal cortex. And then separation immediately made an avoid response. And this is a profound effect, which I've labeled vigilance, freeze, and dissociation. The interpretation we have of this is that this baby goes into a 3-stage pattern where there's a fourth end here. And so when there's a threat, the first response is vigilance. I've got to appraise the threat, its severity, and I can just avoid it. But my mother will protect me. If I cry, my mother will pick me up. That's how I rescue myself when the threat is far away. When the threat is close, crying will kill me. The threat will find me faster than my mother can rescue me. And therefore, freeze is the response mechanism that kicks in. When the threat is just too close, I tune out, I dissociate. Vigilance, freeze, and dissociation is in fact what we saw on that one baby's signal. And I'm coming back to place matters because it's about separation stress. It's separation stress that is the intervention that is studied in primates. And so in primates, the separation stress produces exactly these signals that I've done. So let me harp on my story. Why does increased stress of separation, supine and prone, decrease cardiac output? When you get stressed, sympathetic signals will increase your cardiac output. And yet there's a very clear decreased cardiac output in response to threat. This is a old, vagal, unmyelinated response to a threat. Energy conservation for prolonged survival. I'm sure you're familiar with the work of Stephen Porges that talks about these. And we have something called Jacksonian dissolution. The more threatened I am, the more regressed becomes my defense mechanisms to meet this threat. This is exactly what you're seeing. These babies are decreasing their cardiac outputs because they are dissociating. And all the time, you thought that they were sleeping. Let me show you what this looks like in the 21st century. Here we have a little video. And this method that I'm showing you a picture of here is highly recommended and promoted by many child gurus. It's wonderful. The baby stopped crying and calmed down. Somebody please give Heidelie's ulcer a hug. I'm watching her. Isn't that what you saw, how the baby calmed down? That's what you were meant to see. but you're knit-cap team. So actually, what you see first is a morrow, which is a startle reflex. And then you Heidelie's, what did you see? You don't have time to tell, but what you see is the sequence of vigilance, and then freeze, which is a parasympathetic, sympathetic hyperstimulation at the same time. And then the baby dissociates. You can elicit dissociation in 20 seconds. The more threatened you are, the more regressed is your behavior. And so this is dissociation that you're seeing in these slides. One of the points I like to make with this information is that skin to skin is not prone. you are told never to leave your babies prone because it's very dangerous for them. They will get sudden infant death syndrome. But when the baby is in skin to skin, it's not prone. Is that okay? It's not prone, it's in skin to skin. Prone, supine, skin to skin, different positions. Don't confuse them. I just want to make this little extra point. So, skin to skin is the opposite of separation. Those are contrast opposites, as much as oxytocin and cortisol are opposites. So, and then one little point. The benefit of tilt may be only due to the containment. Idlies, we learn this from your NITCAP. It may not be that they're tilted as much as the fact that they're tied in. I had to tie them up in a shirt to keep them in that position. Otherwise they would have slid off. This is thing. Good. So I'm going to wrap up some conclusions. For the human newborn, it is the habitat which is the determining. The brain program that operates depends on the habitat only. Jaak Panksepp has drawn this picture. Notice there's a place attachment. I've got to put the mask on. There's a place attachment mechanism and pain control buffering of an adult. And that produces integration of emotional systems for social affect. From that base, you can see what's safe and unsafe. And therefore, the place model came from randomized controlled trial that I did in 1897, where we drew skin to skin and separation as two contrasting places. And the overriding question to coming into this building is, am I safe? Stina wants to tell you that there's a fire escape over here, and little blue lights will lead you to it when you... am I safe? Mother is the key to neurodevelopment because she's the place in which the fetus and the newborn feels safe. So there's an order of measuring. When I'm measuring place, and I put it to you this sideways, I'm actually first wanting to know, am I safe? The answer to that question leads to two totally different brain programs, approach or development, which I was able to measure in the frontal lobe in this way. So this is one of Hugo's research. There you see Bartocci, Marco. Is Marco here? Hugo. And so the baby is smelling. The smell bypasses the thalamus and goes directly to the olfactory bulb, to the amygdala. And so the baby's orbitofrontal response to something it likes is to approach. And it only approaches colostrum in the first day of life. And so smell is in fact the key. Smell modulates state organization. And we know that that's, I'm jumping very quickly here, but just to get a message, I'm not detailing these studies as they are. Very specifically, the smell comes from the areolar glands, the Montgomery's tubercles that we used to call them. They produce a smell which is very, very similar to amniotic fluid smell, which is called the reference point for, am I safe? That's the answer to the question, am I safe? The baby must be able to smell its mother's breasts. Only then do you get this biological needs, the synchronized feed and sleep. Notice that I've put play in my little picture there. Actually, the play is about connect, emotional connection. Again, Heidel taught us, what about the emotions? Can babies show emotions? Hugo tells us, do babies have emotions? It's all about emotions, says Jaak Panksepp. And therefore, I did something wrong. The state organization that you see, for 30 years, we've studied babies that are separated. And we've published what that state organization looks like. And it is the state organization. But it is a state organization determined by a higher overriding hierarchical decision. Am I safe or not? And you get a totally different state organization when the baby is safe with mother. Absence of mother makes freeze and dissociation. So repeating this point a little bit from the data that I've worked with, I don't know how many of you recognize this picture from Myron Hofer. And he points out that it's not the mother's signals to the baby, but the baby's mother's interactions that produces regulation. This is the buffering protection of adult support. And I'm using the word mother quite carefully here. And so this interaction, the loss of maternal regulation, is dysregulation. The response to such dysregulation is the release of cortisol. Cortisol reestablishes homeostasis. And here you can see the homeostatic energy, the homeostatic power required. We can measure it. How much homeostatic power is required to reestablish homeostasis? So terminology matters. And I have a little bit of terminology difference with Heideley's Als here. Self-regulation works, but it's hard work. It's a lot of work. Notice the difference in the same baby's regulation, which is co-regulated by the mother. And so when this self-regulation has been accomplished because of earlier co-regulation, a synonym for that self-regulation in my vocabulary is resilience. And so, yes, it's the same physiology, just a terminology, but the mother's regulation, the absence of the buffering protection of adult support is Jack Shonkoff's Early Childhood Development, National Council for the Developing Child in the United States of America and everywhere else, definition of toxic stress. Toxic stress, in turn, produces an allostatic load, a wear and tear, and I don't have time to go into very much more of this. So, I've come to my end. Circadian rhythms and sleep in the developing brain. Sleep, NIDCAP, and future research. What does healthy sleep look like? And so in a week's time, the data that you've seen on these slides will be in the public domain. It was never there before. Guys, you have 1 week to get hold of me and we can do these studies so that we can put these as scientific published data. These are not published data. I can't publish 8 cases. But with your support, we can make this work. Healthy sleep does matter. It is important. And so this is, in fact, my 4-week-old grandchild. My first grandchild. You may congratulate me. And you may congratulate the parents. What does healthy sleep look like? It's the mother, whether you have twins. So healthy sleep ultimately is about feeding and sleeping. James McKenna calls this breast sleeping.
Okay.